Next, we're going to be talking about collision or collidables, which is going to be its own little section. So first, we have the myID value. This is just the ID of the game object, as given by, if we recall, going into Collision Manager, the getTypeID. This is static for every different user-defined type. So all enemies will share the same ID, all bullets will share the same ID. It starts off as undefined because it is not registered for collisions, and then when the user asks to set collidable group, as you can see, we set the ID to the correct one as given by the collidable manager. Moving on, we have the four various states, as mentioned before. Nothing new there. We also have a collision volume B-sphere and a model. These are created on construction, and we need to talk about the collision volume B-spheres. So we'll put a little pointer in this and move over here very quickly. The collision volume class is the base class. We have compute data and two intersect functions. However, they're all virtual, so they need to be overloaded by all children, and they're just fillers. The B-sphere, as you can see, overrides all of those functions, and it also has getRadius and getCenter. And this is literally just a sphere around the model. So if we go into the CPP file, you see compute data basically updates the sphere's position in space to match the model that it's attached to. This is just, so that if the character moves along, its B-sphere, what is used for collision, moves along with it. And we have all that fun little math. And we have our get functions. We can't intersect with the base class, so that just returns false. And then this function returns intersect. Very quickly, let's hop over to Dragon Math just to show you that. Namespace, we have a Boolean that's declared. And then in the CPP file, we just write it all out, and we have our little test here. So going back to the collision B-sphere, as mentioned, we have the intersect there. Other than that, there's not too much to talk about. And this is just a sphere around a model that gets updated and is used for collision. So, back to the collidable. We have our collision registration, deregistration. Again, those are called by the commands, not the user. The user calls submit collision registration and deregistration there. We also have a get B-sphere, which will return the B-sphere used by this model. And then we have set collider model, which sets the model to the correct model. And finally, update collision data. If we move in here, you can see update collision data is just a pass-through function to the B-sphere to update its own data. And again, setting and getting. These functions are there's nothing new here. We've already been over this. Commands, registration states, making sure everything's right, and deleting it at the end. So that's all of collision. Moving on to the inputable. This one, similar to the alarm, has a structure of registration data. This time, however, it uses a map for keeping track of all of the data. This is because using an array a map is very fast at getting the data. So if we need to deregister something, we can pass in the key event pair and quickly get back, okay, this is all of the information that we have on that, and then we can get the p-delete ref and then pass it on to the input manager. The maps are very fast like that. And arrays, we would have to go through it in linear time. So that was out. Next we have the four functions that the user will override for the various events: key pressed, held down, released, and then held up. I don't really know why anyone would want key held up, since that's how it is most of the time, but I had the capability for it. Who knows? Maybe they do want it. So I just have it there in case. Again, these two are called by the commands. We have a big 4, virtual. And then we have submit, input registration, and deregistration, which are called by the user. Before I forget, you may have noticed these documentation blocks. That's going to be me showing the documentation for these objects. I will be going and showing you the website itself after I've gone through everything else. It'll be like the very last thing. And I'll also show the demo documentation then, which is located under this. So this is me showing the documentation that I have. Finally, we have the game object itself. We have our registration states. We don't have a p-delete ref because there's no real game object in scene manager, so we don't need it. These two are called by the functions. We have our functions for the user to override when it enters the scene and when it exits the scene. And then we have submit entry and submit exit for the user to use. Game object, as you'll notice, also inherits from all the other things that we've discussed. So every game object has the capability of everything, and I know we discussed that it's not great, but it's good for our first engine, so I went with that route. Going also within the game object, we include a lot of extra things. These are the ones that we're inheriting from, but we include the managers here so that the user doesn't need to manually include them. That way they have easy access to the model manager so that, when they're setting up, okay, this is going to be my graphics object, I don't have to manually include it. This is more of a convenience thing than a necessary thing, but I kind of like it, so that's how it is for now. Going into the CPP file, it's more of the same. We have registration state, creating the news, asserts, and then we call this scene entry and this scene exit. Nothing too new to see there. One thing to note is that during submit exit, we don't assert, we simply check. If we are currently registered, if we are not currently registered, we just return. That's it. We don't try to submit our exit again. This is so that, again, if multiple bullets hit a guy, and then they all call submit, he calls submit exit multiple times, this doesn't crash and it doesn't go haywire. This prevents it from being called multiple times. And then at the end we delete our commands. So those are all the components for game objects.